Let us use Microsoft calculator app. So if you want to do this kind of calculation as you start this Microsoft calculator, if you are not used earlier in scientific mode, generally it will start in a standard mode. And in standard mode you can see that there are basic arithmetic calculation and there are some power calculation, reciprocal and square root. But in general, you will not find many other things like you want to calculate what is the tan alpha or sine alpha or sine of an angle, trigonometric functions, and so on. So what we do is we click on this button over here, and then you see there are various other converters and other kind of modes. So we go for scientific mode over here, and as you go for scientific mode, you see multiple buttons over here beyond this basic keypad. So you see function like ln, log, 10 raised to x, x raised to y, x square function, square root of this function, 1 by x function, mod x, then exponential, you can take exponent over here, and then basic values of pi or e. So some of these constants. Also, there is a button for second panel. So when you click on that, you get other functions over here. So say I click on this, and now this has become blue, and then you see that I get x cube, cube root, and so on. These kind of functions. So also there is a panel for trigonometric functions, and also there's another panel called functions where two useful functions are going to be there, dms and degrees. Okay, we'll see step by step. Say I want to do this calculation, AB equal to say 23 over here and BC is equal to 65, and how much is alpha? So basically what you want to do is you want to calculate the tan inverse of this ratio, because tan alpha is, here its last function is shown, tan alpha is equal to AB upon CB, okay, and AB is given to you and CB is given to you. So how do we do this calculation? So what you can do is you can simply calculate 23 divided by 65, and you press equal to, and then you get this ratio, and then what you have to do is you have to calculate the tan inverse of this number. So you go to trigonometry, click on trigonometric functions, and then click on second function over here, and then you get tan inverse. So you click on this. Now here what you have to do is first you are writing a number, then you are clicking a function, so it will calculate that function value for the given number, that result which is already there. So we did 23 divided by 65, we got some number, and then that number, for that number we calculated what is the tan inverse, and that number is we are getting 19.4861 and so on. This is in degrees. I want to do this calculation, 17.5 divided by 65, so 17.5 divided by 65, I get this number, and then I want to calculate the tan inverse of this, and I get number 15.068. So 15.068 degrees is the answer here. So tan of this particular number will give me is this particular ratio, 17.5 divided by 65. I want to do 11 upon 65 and find out what is the tan. So I can calculate 11 divided by 65 equal to, I get this number. Sorry, it got pressed double. So 11 divided by 65, and then you go to second function, tan inverse, and it is 9.6 degrees. So this is how you can calculate the tan inverse for particular number. You want to calculate sine of a particular number or cos of a particular number, first put the number, then calculate sine. Say 30 and sine of 30. So I first press 30 and then I press sine, and I know that sine of 30 is half, which is 0.5. If I take 30, okay, and I calculate trigonometric function, cos of 30 is root 3 by 2, so I'll get number like 0.866. So I press this cos and I get that number 0.866. okay, so which is root 3 by 2. So you can work with trigonometric functions like this. I am interested in calculating the sidereal period for Mercury. Okay, so sidereal for Mercury, the synodic period is given to you 115.880. I take a reciprocal of that plus 365.256. I take reciprocal of that. I add them and then take reciprocal. So that will give me 1 by p. So this is 87.97, and you can round off. So it is 87.971. Okay. So those many number of days. So that is the sidereal period of Mercury. You may do the calculation for Venus. So synodic period is 583.9 days, and the period of Earth is 365.256, and you can calculate what is 1 by p. So let us clean this. 583.900, I take reciprocal, plus 365.256, take reciprocal, I add them and further take reciprocal. So 224.697. That is the answer. That is the sidereal period of Venus over here. Okay. So you can do calculation for sidereal period of Venus. Now we can go back and do one more calculation which was done earlier for this full moon calculation. That moon takes 27.3 days to go around Earth. Then why the full moon is the full moon or lunar month, basically full moon to full moon period is 29.5 days. So let's do the calculation. The formula is given over here, and 27.321, that is the rotation period of the moon. You take a reciprocal of that, subtract 365.256, that is the period of revolution of the Earth around the Sun, or effectively the motion of the Sun as seen from Earth, and you take reciprocal of that, and you have subtracted the two quantities, and then you take reciprocal, which is 29.52 or 29.53 when you round off. So that gives you the period of lunar month. So this is how we are doing calculation. Put a number, there is a function of reciprocal, subtract, put another number, calculate reciprocal of that number only, and then equal to. So there is a system of precedence of operation, that one, when whatever number is there, when you press 1 by x, okay, the reciprocal of only that number will come. And so say for example I want to do 1 by 60 minus 1 by 90. So what I do is 1 divided by 60 minus 1 divided by 90. So here when you do 1 divided by 60 minus 1 divided by 90, it will calculate 1 by 60 minus 1 divided by 90. So that minus will be done only after both the divisions are done. So then you get 1 by 60 minus 1 by 90 as 60 reciprocal minus 90 reciprocal, and this is the number, and you can then calculate what is the reciprocal of this. Okay, so that is going to be 180 days. So that was the solar day for Mercury. So 60 days was period of rotation, sidereal period of rotation for Mercury, and 90 days was period of revolution. Okay, so that was basically the motion of the Sun you had considered. And so motion of the Sun with respect to Mercury will be motion of the Sun minus motion of Mercury. Here we had taken the opposite calculation, therefore we got positive number, but motion of the Sun should be 90 reciprocal minus motion of the Mercury itself, which is 60 reciprocal, and you will get this number, and take reciprocal of that, that will be minus 180. So this is the motion of this is the period of the Sun as seen from Mercury, and negative sign indicates that it is moving in from east to west. So Sun will rise in the east, set in the west. So these are simple calculations, the trigonometric calculations as well as the arithmetic calculations you can do here. We can go for power calculations like Kepler's laws. So there what you need to do is, let's take example of say Halley's comet. So we know t square is proportional to a cube, and the period is 76 years. So we are considering approximate 76 here. We are not talking about more precise values. So 76. Now let me just. I can always use calculator in a full screen mode. Okay, and you can use the history, but you don't want history. You can delete, clear all the history. Now here this calculator is not fully transparent, and therefore whatever is at the background part of that will be visible here. But let's focus on the calculation for say Kepler's law. So I was talking about Halley's comet. 76 years is the time period. I take square of that, and there is a button here, so the square of that is 5776, and then I have to take cube root of this, so that will give me E, or semi-major axis. So cube root I can't see here, but it is there in the second function table, and then I press this, and then I get number 17.94. I don't consider all these decimal places over here, okay, because our original data was given as 2 significant digits, so we don't know whether it was rounded off, whether it was 76.0. Right now we are not bothered about that, therefore we can be confident only about at the most one decimal place here. So 17.9 astronomical unit will be the semi-major axis for the Halley's comet, okay, the average distance from sun and the comet. If you consider the other way calculation, like let's take example of Neptune. So you know Neptune, the distance is again 30 astronomical unit, and you want to find out the time period. Okay, so 30 astronomical unit I take here, and I have to take the cube of this. So the cube is, I go to second function, and then there is x cube here. So I take cube of this, so cube of 30 is 27,000, and then I take square root of this, that will give me the period. So when I calculate that, I get 164.316 and so on, but I restrict myself because only 2 or 3 digits, so 164 year is what we can say. 164 years is approximately the period of Neptune around the sun. So you can use Kepler's law this way. You can use square and cube and square root and cube roots to do calculation for the calculation of Kepler's laws using this Microsoft Windows Microsoft calculator. Let us see how this degree, minute, second and degree functions can be used. So for that, first we understand that 1 degree is equivalent to 60 arc minutes. So 1/60th part of a degree is considered as 1 arc minute, which is denoted by this symbol. Similarly, 1 arc minute can be divided further into 60 part, and one part is called arc second. So 1 arc minute is 60 arc second, and 1 arc second is 1/60th of a arc minute, and 1 by 3600 part of a degree. Now if I take 0.5 degree, so 0.5 degree or half degree will be then equivalent to 30 arc minutes, or 0.1 degree will be equivalent to 60 divided by 10, so 1.1 into 60, that is 6 arc minutes. Or if you take 0.01 degree, 0.01 degree will be 0.06 arc minutes, it is 1/10 of this, so this is going to be 1/10. And 0.6 arc minute is same as 6 into 0.1 arc second, 1 arc minute, but 1 arc minute is 60 arc second, and therefore 0.1 arc minute will be 6 arc second. So this total will be 36 arc second. So 0.01 degree will be 36 arc seconds, or you may convert that straight away by multiplying with 3600. So 0.01 into 3600 gives you 36 arc seconds. Similarly, we can further do calculations. Say 42 arc second over here can be written as 42 divided by 60 arc minute. So we are converting arc second into arc minute, and this further can be written as, this is basically you can take a factor of 6 common, and it is 7 by 10, so 0.7 arc minute. You may write 55.4 arc second as 5.4 divided by 60 arc minutes, or 5.4 divided by 3600 degrees. Okay, so you convert arc second into degrees, you need to divide by 3600, 60 into 60. And this, when you do calculation, it is 0.0015 degree. So what you see over here is you get 5.4 arc second as 0.0015 degree. Now we can do all these calculations using the calculator over here. So let's see how do we do that. First, I am interested in these kind of calculations. So say, for example, I have got half degree, and I want to convert that into degree minute seconds. So what do I get? So I first write 0.5, and then this I have written, this I am assuming that I have written in degree format. Then what I will do is I click on this function button, and then I will click on DMS and see what we get. So we get 0.3. Now how do we read this? So we first type 0.5, which is half degree, and it is equivalent to 30 arc minutes. So when you press this DMS button, what it does is the integer part remains in a degree. The first two decimal places are considered minute. The next two decimal places are considered as arc second. So when I get answer here 0.3, it is equivalent to 0.300000 and so on. So first two decimal places is 30, and that makes it 30 arc minute. And next decimal places are all 00, so that is 0 arc second. So half degree is 30 arc minutes. If I write 0.1 degree first, so say I take 0.1, and then I convert this into DMS. So I press DMS here. Okay, so, it got pressed twice. So let me again do this 0.1, and I press this once DMS. I get 0.06. What is this 0.06? The first two decimal places are giving me arc minutes. So 0.1 degree converted after pressing DMS, I get 0 degrees 06 arc minutes. If I write 0.01 degrees and then I convert that into DMS, I should be getting 36 arc seconds. Let us see how is that represented. So I take 0.01. Okay, this number I have put, I am assuming this number is in degrees, and I'm going to press the DMS button so that it will convert the degree format into degree minute seconds. So I click here and I press on DMS, and I get 0.0036. What does this mean? I will read this as integer part is 0, so it is 0 degree. The first two decimal places again 0, so it is 0 arc minute, and the next two decimal places are in arc second, so it is 36 arc second, and we get 0.01 degree, same as 36 arc second. Now suppose I want to do some more calculations. Say I'm getting a number, say 19.25689. Okay, I got some random number as I mean, in some calculation I got this particular answer which is in degrees, and I want to write this in degree minute seconds. Okay, then what I will do is I will press again on this function button, press on DMS, and I will get this number. So my original number was 19.25689, and now I'm getting this as 19.1524804. How do I read this? It is 19 degrees. First two decimal place will give me arc minutes, so 19 degree 15 minutes, and next two decimal places are going to be seconds, so it is 24 seconds, and the further decimal places are fraction of seconds. So the total answer is here is 19 degree 15 minutes 24.804 arc second. This is how I'm going to get answer when you convert degrees into degree minute seconds. Let's take another example. I get a number by after doing some calculation as say 45.2525. Now this is the answer in degrees, 45.2525. Okay, I'm assuming that this number is in degrees, and then what I will do is I want to convert this into degree minute seconds. So when I press the DMS button, I'm going to get 45.1509. What is this? This reads 45 degrees 15 minutes and 9 seconds. I expect that because 45.25 is 25 is 0.25 is 1/4. So 1/4 of a degree is 15 arc minutes. So you expect 45 degree 15 arc minutes, and again further there is 0.0025 arc minutes, 0.0025 degrees, which you convert into arc second, and you get 9 arc seconds over here. So we can convert degrees into degree minute seconds, or fraction of degrees into degree minute seconds like this. We can take the other way calculation. So if I want to other way calculation, say I want to convert 42 arc second into some degrees. Okay, so what do? So I take 42 arc second. Remember, it will be third and fourth decimal place. So 0.0042. Now I am assuming my number format is degree 2 decimal places for minutes and rest 2 decimal places for seconds. So here again I am making an assumption that this is, when I am typing a number, I am making an assumption that I have a written number in degree minute seconds, but I want to convert this into degrees. So what I do is I press function button, and now I will press this into this degrees. So convert this into degrees, and what am I getting? 0.0042 which is 42 second, okay, is this fraction of degrees, 0.011666 degrees. If I convert this into arc minute by multiplying with 60, I should get 0.7. So I multiply this with 60, and what do I get? So I get 0.7. So what we have done, first I wrote the number. This is for conversion purpose, 0.0042. I am writing a number in DMS format, so 0 degrees, 0 minutes and 42 seconds, and I am converting that into pure degrees, and I get this number. This number is in pure degrees. So 42 arc second is equivalent to 0.011666 so many degrees. This is equivalent to 0.7 arc minutes. That we can, you can multiply by 60 and you can verify that this is same as 0.7 arc minutes. Let me take 5.4 arc second. How do I write 5.4 arc second? Okay, which is supposed to be 0.0015 degrees. So what we will do is, first we will write 5.4 arc seconds. And how do I write that? 0.00, the first 2 decimal places in DMS format is for arc minutes, and I want 5. The next 2 decimal places are seconds, but I have only 5 seconds. So 0.5, and next decimal place is going to give me the fraction of second. So I write 4. So here this number is in DMS format. I am writing the number and I am assuming that it is in DMS format. So I take 0.00054, which is same as 0 degree, 0 minutes and 5.4 seconds, because the third and fourth decimal place will give me second, and after that will give me fraction of second. I want to convert this into degrees. Okay, so what I will do is I will click on this function button, click on degrees, and I get 0.0015 degree, which is expected. So by doing such kind of practice, you can convert degree minute second into degrees with fractions, or you can convert degrees in fractions into degree minute seconds. Where does this become useful? In astronomical calculations, typically the data, when you get the data given, will be in degree minute second system. You want to do calculations on sine, calculate sine of that or cos of that, then first you need to convert that into degrees, then calculate sine cos. Okay. Similarly, if you are writing some fraction, okay, and you are getting some tan alpha value, and you want to convert that into alpha, so you do tan inverse function and you get number in degree with fractions. But astronomers prefer data which is written in degree minute second format. So once you get the answer from inverse trigonometric functions into degrees, you can use DMS function and convert that into degree minute second format. So when you get data in DMS format, you type in DMS format, convert that into degrees, then you calculate the trigonometric functions. When you already have a ratio, you take the inverse trigonometric function to get degrees, and you want to represent that in degree, minute, second. Then you press DMS button to convert the degrees with fraction into DMS.